Welcome to the second section of Binance Academy's dApps Deep Dive course, where we'll have a comprehensive overview of smart contracts over 4 modules. In Module 2.1, we'll take a closer look at smart contracts, its history, and how it works. Smart contracts are at the core of all dApps backend, but when and how were smart contracts come to be? The term smart contract was first used by American computer scientist Nick Szabo in a paper he published in 1994, over a decade before blockchain technology was born. In the paper, Szabo described a smart contract as computerized transaction protocol that executes the terms of a contract. He went on to explain that smart contracts are meant to satisfy contractual conditions such as payment terms, liens, and even enforcement. This is done to minimize both malicious and accidental breaches, while reducing the need for trusted intermediaries. Interestingly, Szabo clarified that the word smart does not imply the usage of artificial intelligence, as it often is associated with terms such as smart speakers and smart meters. Szabo named it smart contract because these contracts are far more functional than their paper-based ancestors. Nearly 20 years later, Szabo's theory came to life on Ethereum when smart contracts were applied to blockchain technology. The crypto industry has since adopted smart contracts because of their ability to broaden the functionality of blockchains, making smart contracts the backbone of dApps. As a result, today's smart contracts are primarily disintermediated and trustless compared to its initial conceptualization. So, how can we define what a smart contract is? Smart contracts refer to deterministic computer programs that run on the blockchain when certain conditions are met. Smart contracts execute predetermined tasks automatically if and when certain conditions are met. Therefore, a smart contract follows the if this, then that coding statement. Being deterministic means that there are only 2 outcomes for a smart contract. Either the condition is met and the smart contract gets executed automatically, or the condition is not met and the contract doesn't execute. This way, smart contracts facilitate the transfer of digital assets while allowing specifications of conditions for transactions. Besides Ethereum, many other blockchain networks, including BNB Chain and Cardano, support smart contracts. Outside of the cryptocurrency industry, traditional businesses are also utilizing smart contracts. For example, retailers can use smart contracts to resolve disputes with vendors quickly. Let's take a closer look at smart contracts on Ethereum, the leading blockchain network for smart contracts. First, we need to understand the Ethereum network's 2 account types: externally owned accounts and contract accounts. Externally owned accounts are controlled by those who have the private keys to access them, such as users who hold Ether. Contract accounts are smart contracts that are deployed to the network and controlled by code. Smart contracts are contract accounts deployed to the Ethereum network. They have a balance and can be the target of transactions. EOAs can interact with smart contracts by submitting transactions that execute a function defined by a smart contract. It's important to note that the Ethereum network enacted a standard in 2023 to allow the creation of a single account that combines features of both EOA and contract accounts. Ethereum also supports multi-signature contracts that require multiple valid signatures to execute a transaction, a good example of how smart contracts can be used to avoid single points of failure. Not only are smart contracts permissionless and trustless, but just about anyone can write a smart contract and deploy it as long as they have enough Ether to pay for gas. Smart contracts are public and can be considered open APIs. Furthermore, you can call other smart contracts in your own smart contract to extend functionality. So smart contracts sound great, but what can they be used for? Well, they can do everything that computer programs do, with the added benefit of privacy protection, complete transparency, and composability, while being permissionless and trustless. Smart contracts can be used for applications ranging from the creation and distribution of digital assets, minting stablecoins, and creating unique digital items like NFTs, to powering decentralized exchanges and decentralized gaming. In the next module, we will learn the steps to write and deploy smart contracts on the Ethereum network.